All right, guys, we've been looking at systematic approaches to solving 3x3 systems. And so we do all this work, but why are we doing it? Well, I got to tell you, this is kind of our culmination of all of these efforts here. We want to be able to work with application type situations in which we have more than one unknown, but a lot of equations also to work with. So what we're going to do is we're going to take a look at the steps we go through in order to do a quote unquote word problem. And to put you at ease, because you can always complete these steps and find success if you feel good about setting up your system, okay? So what we're going to do first really is we're going to read the problem here and kind of try to familiarize ourselves with what's going on. So reading through this, it says 3 orders are placed at a pizza shop. 2 small pizzas, a liter of soda, and a salad cost $14. 1 small pizza, a liter of soda, and 3 salads cost $15. 3 small pizzas, a liter of soda, and 2 salads cost $22. Our job is to determine the cost of each item. So that sounds like a whole lot. But the thing here I want to indicate is just that when you read these problems, chances are the very, very last sentence is going to flat out tell you what it is that I want you to do here. So determine something. And in this case, all we want to do is determine the cost of each item, which I hope you noticed there were 3 items here. And I hope you also noticed that up here in the description, there were like 3 different constraints or 3 different orders. So what that's going to do is it'll allow us to set up some unknowns, things we're looking for, and set up 3 equations to solve a 3x3 system and find these unknowns, these costs. So rule number 1, or at least step number 1, let's go ahead and put some steps over here. 1, we are going to read the problem carefully. And the second step is going to be this: define your variables. So how do I know what I need to define my variables as and how many variables I need? The fact is, when we read through this problem here, it says to determine the cost of each item, we can imply from the problem there, infer from the problem, that there were 3 items. So chances are we need not just an x and a y, but we need an x and a y and a z. So where it says define your variables, I'm going to make a subnote here. This is likely, or they are likely mentioned in the last sentence of the problem, okay? And that is to say that usually somebody's going to ask you to go find something, and this is unknowns in this case. So once we've defined our variables, we're going to set up and solve a 3x3 system. And last but not least, we're going to interpret our variable values of the solution, or the ordered triple that we get. So all these put out here, we're going to walk through these steps one by one here. But what I want you to notice is I've already done a lot of the work for us here. So after reading this last sentence, I know I'm supposed to read it and then define my variables. It says determine the cost of each item, and that is to say that there were 3 items. So over here, we're going to pick a spot where we say these are our variables, and we literally write definition of variables. You'll notice that in every possible instance, I need to see certain things. So I will tell you that hands down, we must be writing let x equal, okay? We have 3 variables, so we're also going to write let y equal, let z equal. And the other thing that must be written is, on the right-hand side, it must be the number of something. So you don't just say let x equal pounds, let x equal dollars, because if x is dollars, man, I can go to the store and spend x's instead of real money. We need to indicate that these represent numbers of things. So the number of what? Well, if we're finding the cost of each item, then we're going to find the number of dollars per, say, our 3 items, which were respectively the small pizzas, okay, the liters of soda, and the salad cost. Next thing up is just going to be this really quickly here. But why did I do pizzas, soda, salad? Because when I read through the problem, they kept presenting it in that order: pizza, soda, salad. I want you to know that you can mix these up. It's just going to change the way your system looks. Now, that was step 2. What we're going to do now is set up our 3x3 system and solve it. You'll notice that I already have my 3x3 system set up here. So again, underneath your variables, you're going to find a spot where you're just going to write the word system. And underneath, we're going to write in our constraints for our equations. And these were things that we just found from the problem above. So for instance, if you want to know where I'm getting this 2x plus y plus z equals 14, it said 2 small pizzas, which the cost of a small pizza is our x, so 2 of these x's. And so plus 1 liter of soda, which we're representing y to represent the cost of that, plus 1 salad, so 1 times the cost of a salad. This should come out to be $14 here. So as you read through this, we can kind of set up our constraints based on what we saw was the verbiage in the problem. So, you know, a small pizza plus a liter of soda plus 3 salads was $15. You can see that That's what my constraint says, but that's what it also says in the problem. So now, let's go through and actually solve this bad boy, because I got to show you, we've got to interpret our results, guys. If you find an x, y, and z, that's great. But if your job is to find the cost, telling me x, y, and z doesn't tell me a whole lot. So looking at solving this, we're going to go ahead and put our indices out here. 1, 2, 3. And I think that what I want to do is, let's go after our y's. It'd be really easy to work with y's. So I'm just going to tackle equation 1 and 2 here. Since they already have the same coefficients on the y's, we're going to have to make one of them negative. So our equation 1 is this. Our equation 2 is x plus a y plus 3z's, and this is equal to 15 here. And let's go ahead and multiply just for fun. We'll multiply the first equation by a negative 1. So we'll rip this through that scalar, and we're going to write this underneath here. I suppose we get negative 2x minus y minus z is equal to negative 14. And our second equation stayed static, is static. Did not change. So our y's, boom, they eliminate. We get negative x. Looks like we get a plus 2z, and this is equal to a constant value of 1. I'm going to box this. So now, I traditionally put this underneath again, except this time I can't use equations 1 and 2. I'm going to use equations, say, let's do 2 and 3. So equation 2 was x plus y, or is x plus y equal plus 3z equals 15. And our third equation here, that's 3x's plus a y plus a 2z equals 22. And let's multiply our first equation by a negative 1 to scale our y coefficient here. So underneath, we'll scroll down here, a little bit of room. We get negative x minus y minus 3z equals a negative 15. And again, our second equation here we did not modify in this particular instance. So plus 2z's equals 22. Let's add these up, getting our y's to cancel. We get left with 2 x's. Okay. Looks like we get left with a negative 1z. And 22 minus 15 is a 7, lucky number 7. So remember how this works. We set up our 2 by 2 system now that we have two equations with the same two variables. All right, negative x plus 2z equals 1. We also have 2 x's minus a z equals 7. And it looks like, I don't know, we could eliminate x's or z's. I'm going to opt to eliminate my x's. So I'm just going to double my first equation value. So I'm going to scale that by a factor of 2. So rewriting this again, negative 2x would be plus a 4z, okay? And this would be equal to 2. And our second equation, again, we did not modify in this particular instance. And so what we get is our x's dropping. Looks like we get 3 z's left over, and we get left with the constant of 9, which is really cool because when you divide both sides by 3, we get z equals 3. So again, remember what we've done in the past. We pick a spot, we get really excited, we say our solution is da-da-da, and we know the z part is trace. So now, how about this z? Well, we're going to plug it back in to either of these two equations in our 2 by 2 system to solve for x, and I'm going to opt to plug it into the first one. So I'm real big on rewrite the equation. Negative x plus 2z equals 1, and then go make your substitution. Negative x plus 2 times 3 equals 1. Looks like we get negative x plus 6 equals 1. When we subtract that 6 over, it makes this side a negative 5. So what I'm going to do is I'm going to say that x is equal to 5. I'm going to race back up here and say x is 5. Remember that this last step involves saying that we know 2 of the unknowns here, so let's pick an equation from the original system, since 5 and 3 satisfy all of them, and go back and solve for y. And the easiest one to probably work with, I think, is probably the second equation. There's 2 variables that have coefficients of 1. So again, rewrite the equation. The second equation was x plus y plus 3z is equal to 15. And what we're aware of at this point is that x has a value of 5, and our z value has a value of 3 here. That means that we get 5. This is a 3 here. Let's simplify. So we get 5 plus y plus 9 equals 15. And combining these like terms here, we get y plus a 14 on the left equals 15. This is really cool. It means that we get y as 1. So we're going to put our 1 in here, and I want you to know this. You should do your happy dance because we found the solution that existed. But remember that the step 4 is going to be to interpret our variable values in the context of the problem. So what is it that we were using to x, y, and z to represent? Remember, x is the number of dollars per small pizza. So we can look at this as it costs $5 per small pizza. Y is this $1 cost per soda, and z is this $3 per salad. So I'm going to tell you that you need to pick a spot to write this out in because you must give a conclusion, and that's what I'm going to do here. So just to show you, conclusion, and if you're not sure what to write in your conclusion, read the last sentence of your problem. Determine the cost of each item. So I'm going to write the cost of a small pizza is $5. of a small soda, of a liter of soda, is $1, and of a salad is $3. Okay, so this conclusion really is what we're after. We certainly set up and do a lot of work to get there, but this is kind of the idea. So get really strong with solving your 3x3s, but also get really strong with just setting up your system. Cheers.